We'll try to present a video. So this will walk through a fulfillment center. You could see what are the latest advancements that are being made that are implemented in a fulfillment center around robotic arms or automated guided vehicles. This would be a brief 10-minute video, and after that we could take a deep dive into the concepts.
One of the things we miss so much
during COVID-19
is not being able to take you through our fulfillment center
in person.
We're still here and working hard to get your parcels delivered safely.
And we felt we'd take the chance
to bring the tour to you, wherever you are. So welcome.
Welcome.
So welcome to Set 2.
À Louvain-Blanc en France.
Welcome to the Amazon Fulfillment Center Tour. We're really excited to be showing you around our building.
Hi everybody, my name's Paul, and I'm going to be your first tour guide of the day. Today, we're in Rugeley. This building is one of our Amazon Fulfillment Centres, or FC for short. This building is 750,000 square feet, or 10 football pitches if you want a comparison. All of our buildings are named after the nearest international airport. The nearest international airport to this building is Birmingham, so this building is called BHX1. And I think you'll agree, the view from where we are now is quite spectacular. This is Sarah, and Sarah's making one of our famous boxes to turn up at your doorstep. Thank you, Sarah. This box has been on quite a journey, but let's go and see where it all started. So let's go and see Adam at Receive.
This is where the whole process starts from. It's actually a combination of people, technology, and high-tech computer algorithms. Over half the items sold on the Amazon website by our small and medium-sized business are done this by using Fulfilled by Amazon. Now, this is where we will bring the items in, we'll pick the items, we'll pack the items, we'll ship them out, and we'll even take care of the customer services for them. And more businesses are taking this up each year. As the items make their way up the conveyor belt, one of our associates will take the items off and will scan the barcode that is on the items. Now, once we've done this, we will then place the item into a black tote. Once it's the items inside the tote, it goes back onto our conveyor belt, which lets us distribute the item throughout the FC, and it will make its way to our stowing area. So we're going to go upstairs, and I'm going to pass you over to Tony.
Now that we've received our items, they're now ready to stow. The way it works is that we scan our item's barcode, we then check it for damages, we then pop it onto the shelf, and then we scan the barcode of that shelf location. Once it's on there, we know exactly where the item is at any time, and we can immediately go to that when we go into our next process. This method of stowing has been very successful. However, over recent years, we've developed something even more exciting. So let's head over to our robotics site with Marta.
Hi folks, my name's Martha and I'm here in Dunstable at one of our cutting-edge Amazon robotics fulfillment centers. This building is what we call LTN4. Do you remember the naming system? Perfect. The Amazon robots are activated once the associate logs into their working station to perform his or her task. The robots are bringing yellow shelves to our working stations where our associates can fill up pods with more products, or we can pick up your orders. This is one of our shelving units. Our orange rectangular robots are going underneath these pods, and the lifting device is picking up a shelf just a bit from the floor so it can be moved to our working station. Let's see our store station so I can show you how we are filling up pods with the products. Our associates are asked to assign containers to themselves. The next step is to pick up an item from the container. Then we just have to scan this barcode and find the space in the shelving units for this product. Probably you're wondering if the system tells us where we should put this product. It's completely random. We call it random store method. So that means that The most popular items are spread across all the levels and not all in one place. After the process is completed, then we got digital and physical match in our system, and all these items are available on our website for the customers.
At Amazon, we are continuously looking for ways to make improvements. And this robotic arm is one of our newer features. It's actually called a palletizer, and it helps us move heavy totes around quickly and safely.
Once you hit Buy Now button on Amazon website, this is the beginning of our outbound operations processes. Once you order a product, the information about the item will go to our system, and then the robots will be informed about which item you've ordered and where it is located. Then the robots will pick up a pod and bring it to our working stations facing correct side. And then it's quite easy. All the informations are on the screen. Then we just have to pick up the item from the shelf and put it to the correct container. In one container, we can have products ordered by several different customers. If you would order, let's say, 5 items, it's really rare that one picker only will pick up all of your items. More likely, they will be picked up by several different pickers. All the items you could find in this building fit into our containers. We also sell bigger items, such as kayaks or TVs even, and we store them in our so-called non-sortable fulfillment centers. Once your products are picked up, they will travel in a tote down to our multi-pack area, where they will be packed by our associates.
And here we are in the flow room at LCY2. This is where operations to my right are watching the workflow to make sure everybody's delivery is leaving on time. To the left of me here are the engineers. These guys are watching the conveyor belts. We have 16 miles in this building, and they're making sure it's all working smoothly.
This is pack. This is where all of your items end up after they've been picked, and they will then come down the lines and they'll be sorted into single pack and multiple pack. Just behind me, I have Sebi packing on singles today, and he's putting one item inside each box. Everything that they need is here. So all of their boxes, their envelopes, and their tape is always on this station or easily accessible. And they do move around onto different processes as is required. So what he'll do is he will scan his item onto the system. It will tell him exactly what size box he requires. We then have the tape that is cut exactly to the size of that box, so we do not waste anything. Once he's finished packing, it will then go onto the line and then sent down to SLAM and then to shipping. Now that we've finished packing our box and popped it onto the conveyor belt, it's now going to come to what we call SLAM. SLAM stands for Scan, Label, Apply and Manifest, and this is where all of our parcels pass through before going down to shipping. This label is applied by a little bit of air pressure, and each of these parcels is going to be scanned with the little white barcode that we applied at the pack station. And each one of these barcodes is going to identify what's inside that box. Once that's been scanned, it will then go through into the system automatically, and it will tell the system which address label is required. Once these parcels have continued through this part, it will get separated into large and small boxes, and these will continue down to shipping. What's pretty cool about this machine is that it can do this whole process without stopping the parcel. So that label is applied straight away, and it continues and generates within a matter of seconds the next label. This is our final stop. This is shipping. This is where all of our parcels end up. They're going to be sorted, and then they'll be sent onto the trucks via pallets and ATS carts. As you can see behind me, we have some chutes. These are where our parcels are sorted and sent down the lines. So each one of these conveyor belts is a different distribution centre. And as workers behind me are going to scan those parcels and send them off onto the correct pallet or ATS cart. And then they will then be scanned into the truck that needs to go to that area. Our trucks, they come throughout the day. They are given a time slot when they can come into the back of the building, and then they have a certain amount of time for those parcels to get inside that truck. Once it's loaded, they will then close the truck and send it on its way. This This is the last stop of our tour. Thank you so much for coming around with us today. We hope you keep safe and we hope to see you in person on one of our tours soon.
Thanks for taking our tour today.
It's been a pleasure.
Show you around.
Yeah, so that's a good 10-minute video around how a warehouse, a typical warehouse, would be operating. So in that we have seen a lot of uh, mechatronics or robotic features, right? Like we have seen robotic arms, we have seen automated guided vehicles, we have seen a labeling system, which is like which scanned the barcode and it had generated shipping label within seconds while the other parcel is arriving. So there are a lot of AI and deep learning uh, features that have been infused into mechatronics and robotics. And Shishi, would you like to cover from a high level on the main operations and the remaining sites?
Yeah, let me take it from here. So I think as Karthik has probably pointed out, so the three main operations within a warehouse. A warehouse is really a storage system where you store items. So the toughest part of a warehouse is how do you arrange your items? How do you move items within it? And the main operations are essentially broken down into an inbound, outbound, and a maintenance operation. An inbound operation is essentially where your sellers send items to the warehouse. An outbound operation is where you take items from the warehouse and give it to your end customers. So in between is where the storage part happens. So again, to summarize the video, inbound has four major components: storage systems, unpacking, placement, planning of parts, making decisions. That is, where should big items go? Where should small items go? So you'll have a whole lot of routing problems, movement problems, storage problems. So different warehouses take different approaches towards storage. Some take the warehouse to the store, some take the store to the storage area. And there are all sorts of automation options that are available these days. So depending on the amount of mechatronics and robotics capability that you have, different warehouses take different approaches. So, and moving to the outbound part, I think the main challenges in outbound are usually delivery systems. How do you plan your delivery? And within delivery, I think drones are one of the most upcoming and promising problems that we see these days. Though no successful solutions.
Sasi, 1 minute. Just can you increase your voice volume? It is a little bit low.
Just let me check. Okay, I'm already on full. Is this good? Hello?
I think it's good. Yep.
Yeah, okay. So yeah, back to outbound. So I think drone delivery is one main system that is being very, very challenging and we haven't had promising results as of yet. But there is also an automated delivery system that various e-commerce sellers have been trying of late. So packing system, as you have seen in the video, I think there's a slam system and also a packing system that automates all your packing related infrastructure and the exact dimensions that are required for packing. So that's one main challenge within outbound systems. So coming to maintenance part, usually sometimes you miss out on items, sometimes you miss out on the structure of the warehouse. That is, the warehouse itself does not look in the same shape that it's supposed to. This is where sometimes human maintenance is required. So the problem when humans and robots are interacting with each other is it's not straightforward. The robots should know who is a human and who is not a human. So this is where some interesting human computer interaction problems show up. Yeah, Karthik, can you go to the next slide?
Yep.
So within inbound, one of the challenging problems is how do you pick an item and put it in one of the containers? I mean, if you have seen the video, there are some places where you have to actually, humans are essentially picking the items and putting them in various boxes. But eventually, what you want to do is you want a robotic arm to do that for you. At this point, there is no straightforward solution that does it. To actually, the final storage point is where I think a lot of interesting, challenging problems are there. Other than that, you have a whole lot of routing problems. That is, you need to guide your automated guided vehicle systems to take the shortest path from one point in the warehouse to the other point. That's where most of your hard computer science problems or NP hard problems show up. So there's some really promising technological improvements that are going on here, like quantum computing. So over the next 2 years, you'll see a lot of improvements and optimizations going on in this space. So there are few Indian ASRS systems, ASRS being automated storage and retrieval systems. So what you saw in the previous video was a robotic based storage and retrieval where the robot comes to you, takes the item and goes back to its location. But most of the ASRS systems are essentially driven by a container that comes to you through a conveyor belt, and then you load it up with some items, and then it goes back to a storage system and it gets fixed somewhere in this ASRS system. So ASRS systems largely are vertical based. That is, as your warehouse increases in size, you can start adding more and more layers on top of it. And then there are automated moving systems that can pick items from anywhere and put it anywhere. These are not entirely guided like the robotic system that you saw, but some of these are linear. That is, they have specific paths and they only follow those specific paths. Yeah, I think that should give a brief overview of what are the interesting challenges that we have and what's solved so far. Karthik, can we go to the next? Yeah, probably I think what you see is just a summary of some of the interesting problems that are left around. You have drone delivery system that has not yet been completely solved, and then you have unpacking systems, which are still a challenge because most unpacking materials are of variable size and you don't know, each vendor has his own size. So that is not yet a solved problem. And robotic arm picking and stowing is another unsolved problem that we have. Packing systems are semi-automated, but still we have some way to go on automated packing, which requires some amount of robotic arms and also automated slam and systems. Yeah, I think that should give a
Yep.
brief summary.
Yes, thank you, Sashi. So now we
Thank you.
have went through a brief video where how robotics and mechatronics have been coming into picture and how these are trying to solve the most challenging problems in a warehouse. So let's try to understand how these systems work, how an automated guided vehicle work, how does a drone operate, how does it go from point A to point B without manual intervention, uh, how does a vacuum cleaner work? Like you see here, right? You see uh, a robotic vacuum cleaner. This is called iRobot Roomba. How does this work? We'll start with that. We'll take that as our base case. You have seen like in the warehouse, you have a similar device which lifts the shelf and it navigates through the warehouse. So let's try to understand how does this uh, vacuum cleaner, the robotic vacuum cleaner work. So what it's trying to do is when you first buy and when you leave it on the floor, it tries to explore the entire floor. So it tries to understand the environment. It will try to understand the environment and it will try to interact with the environment. And as it interacts with the environment, as it sucks the dirt from the floor, there would be a counter inside which would increment its reward counter. So as it collects more dust, the reward counter increases, and that's how the robot knows that okay, if I collect more dirt, my reward count increments, and I need to perform in a much efficient way to collect more dirt. That's how it tries to navigate, and it tries to perform the same action, which will give a good reward. So that's how you see on the right side there is a picture which is depicted. it could be a drone, it could be an automated guided vehicle, or it could be a simple vacuum cleaner, a robotic vacuum cleaner. So it performs, it interacts with an environment, it performs an action, and it gets a reward. It could be a negative reward or it could be a positive reward. And as it performs an action, as it gets a reward, it needs to move to a different state, and again it performs an action, it gets a reward. So it tries to be in that continuous cycle by interacting with the environment. And I think we can relate this to a video game. So I think most of you have played video games. So initially, when you play for the very first time, we might not be scoring a good score, but we try to interact with that environment. We see like where what actions will give more rewards, what actions will give a negative reward. Like maybe we might be losing one of our lives while playing that video game. Uh, Doing some moves, we might be treated with more points or with some coins. So that's how we all the reinforcement learning happens through interacting with the environment. So even here we could see like a drone delivery. In the initial iteration, it started at a point and it needs to go to a landmark, which is its destination. It had taken multiple routes where a couple of them are pretty long. But after a couple of iterations, at eighth iteration, it had picked up its shortest path. So now the drone is smart enough to understand, okay, the main target is to navigate from point A to point B within the shortest distance. So that's how the automated guided vehicles and drones or the floor robots that you saw operate. It's all reinforcement learning. So even here we could see like this is the Pac-Man game. Even the Pac-Man is trying to interact with the environment, and the reward that it gets is the score. So reinforcement learning, it's not a supervised learning. It's neither a supervised learning nor an unsupervised learning. So basically, in supervised learning, we have a labeled data, and the model operates by learning the labels, and it tries to predict according to that label data. In the unsupervised learning, it tries to find a hidden structure or a pattern in the data that we feed to. Basically, we could treat that as a clustering. So learning what to do, how to map situations to actions so as to maximize a numerical reward signal. So that's a classic definition defined by Sutton and Bartow uh, about reinforcement learning. And there are a couple of different types of reinforcement learnings. One is model based, and the other one are like model free methods. So generally, in model free method, you are not bound to a policy, or you are not bound to uh, some restrictions. It's like a free arena where you go, you explore. It's most of like most of them it's trial and error search. So basically, when we talk about these robots, right, to interact with the environment, we generally prefer a model-free method so that the robot could interact with the environment, learn from the environment, understand the reward policies, and it tries to optimize its performance as it learns by interacting with the environment. So that this is around like reinforcement learning. So in the previous session, I heard some of the questions around how could we motivate mechanical or mechatronics engineers. So infusing the deep learning, the reinforcement learning concepts to the robotics that you work on. So those would like do those can do magic. So and we have already discussed what problems currently all these warehouses are facing, and there's huge scope for robotics and reinforcement learning put together. So let's move to the next concept. So here I would try to give a classic example. I'm trying to do like a reverse engineer. I threw the toughest concept called reinforcement learning, and now I'm taking you guys back to a basic concept called machine learning. So here we see this is a GPU. It's an external GPU. It's just like A80. It does not have generally GPUs. They come with a cooling fan. So the fan speed is affected by the temperature of the external GPU, or the amount of work that or the number of processes that are running in the external GPU. The temperature increases. Based on that, it has its own uh, fan system, cooling system. But Tesla KD does not have that. So what I did was I created I got this Arduino board, and I connected the thermostat to the Tesla K80, and I connected a fan. And based on, and when I start running my deep learning algorithms, the Tesla K80 temperature increases, the thermostat recognizes the temperature, and the Arduino board tries to control the speed of the fan. Um, Maybe I'll try to. I hope you should be able to see this now. Yep. So yeah, this is the GPU, and this is the fan that I connected. It's a PWM fan, and thermostat is like stuck inside. This is the thermostat, and these both are connected to an Arduino circuit. So this is the Arduino board circuit. So based on this now, as I operate my external GPU, let me switch off my AM because the bandwidth. Yeah. So based on the processes that run in the GPU, the temperature changes and the fan speed is controlled. So this is what I'm trying to explain. So it's a basic. Let's again take a step back and talk about Charles' law, like volume and temperature. Volume and temperature, they are directly proportional, which are positively correlated. So if we draw a regression line where V equal to AD plus C, you would be getting a simple regression line. And given V value, we can calculate the T value. Given the temperature value, we can calculate the volume. Given the volume value, we can calculate the temperature value. Pretty straightforward. But what if this is an open ecosystem, and there could be external factors that would affect the volume. So let's say you have like the pressure, the wind speed, the heat index, time of the day. And if we start putting all these factors into an equation, we might be ending up like, let's say volume equals some coefficient times temperature, some coefficient times pressure, some coefficient times speed of the wind, some coefficient times heat index, and time of the day. Now, this is what we call like a regression. So if we start putting this in a plot like how we saw in volume and temperature, that's pretty challenging. We cannot visualize. Human mind cannot visualize more than 3 dimensions. So that's where we could talk about like dimensionality reduction and all those. But from a high level, this is what a linear regression is. You try to predict a labeled data, your output value y, with reference to the independent variables, which could affect the output, your dependent variable y. So let me take, oh yeah. So let me throw some points around the basic machine learning concepts here. So let's start talking about supervised and unsupervised learning. So supervised learning is if you are learning a task under supervision, like someone is uh, present there to judge, and from where you are getting the right answer, whether you are getting a right answer, or how good your prediction is. If someone is judging that, or if you have a reference values with which you could compare, so that's where it's called supervised learning. So if you know your V values and volume values, and you have your dependent variables, you have your independent variables, then that's more, we could relate that to a supervised learning. Unsupervised learning, it's more around you don't have labeled data sets. All you would try to do is explore the data points, try to identify some patterns, and see if you could come up with some clustering of the data points. So that's around unsupervised learning. So now in supervised learning, we could fairly divide supervised learning into linear and logistic regressions. Linear regression, it's more like what we have seen in the previous slide. You have your input values, you try to predict an output value which is dependent on your input values. Logistic regression is mostly referred to as classification, like true or false, yes or no, zero, one, uh, like detecting a fraud. If you get an email, you want to detect if it's a spam email or not. Like zero is spam, one is not spam. That's where logistic regression comes into picture. And every data, right? All the data points that you feed into has some bias or variance, and this drastically affect your models that you work on. Uh, like as the complexity of the model increases, your variance also increases, and if your model is at a high error rate, there could be there could be a chance that it has higher bias. And underfitting and overfitting, if your model is working good on trained data set and it's not performing well on the unseen data, so that's where it is like overfitting. And if your model is not performing good on trained data but it's performing well on unseen data, that's when you call underfitting. And we can also see here you have the linear and non-linear models. Uh, Linear models where your uh, parameters are linearly dependent. That's where you could treat them as linear models. And on the other hand, if your parameters are not linearly related, those could be called as non-linear models. Let me okay. Let's take a dive into deep learning. So now we have seen reinforcement learning, which is more exploring the environment, understanding what actions should be taken. And machine learning is more around you have your input data points. The classic example that I showed you, right? You have a processor, it's running some processes inside it, and based on that, the temperature changes. You have a thermostat connected, and you have a fan that's cooling. You could ask like, hey Karthik, the Arduino board is doing it, right? Why do you need a machine learning regression model for this? Let's scale this up. Instead of a simple GPU, let's scale it up to a huge manufacturing industry. You have a factory which is operating, and you have some manufacturing processes that are working. Now you need a huge cooling system to cool some of the components. Now we can't go and connect thermostats at every point, right? So you need to have sensors which could detect that heat index and send this information as signals, as data points to these cooling systems. Now, how we could make this cooling system smarter? So that's where the regression comes into picture. When you know the correlation between these data points that are coming through your heat sensors or some wind sensors, number of workers in the factory at a given point of time, then the amount of oxygen that's being pumped into the factory for ventilation. So all these points, all these data points have some correlation to the cooling system that needs to cool the entire manufacturing plant. So you could have Arduino boards at each and every location, but from through these boards you could try to get some data points, and we could draw some machine learning regression models which would make the cooling system smarter to perform at higher efficiency. So that's the point, like how we are correlating, or how we scaled up our simple GPU example to a manufacturing example using the machine learning. Let's talk about some deep learning concepts here, because your computer vision or your NLP, um, and some of the deep neural nets, they all work with around the deep learning framework. So technically, deep learning, it has it's a neuron system. It has multiple layers of neurons. Again, neurons are nothing but imagine our brain. So our brain neural network has neurons. So these neurons, they talk to each other. They send information, they send data to each other through electrical signals. Likewise, in a deep learning framework, you have neurons at each layer. You have an input layer. From these input layers, the data points, the data goes, and it feeds an hidden layer. You could have one or multiple hidden layers based on your use case. And all these hidden layers, they would compute, and they would send an final output signal to the output layer. So in here you could see, like, in a hidden layer, let's say you have x1, x2, x3, so on, xn, n number of neurons, and each neuron has weights like w1, w2, w3, so on, wn. So you could have an intermediate layer which is like a sigma operation, which is a summation of x1 w1, x2 w2, which is a function, so that could give an output value. So that's how the computation happens in a neural network. And now let's talk about, like, the robotic arms with cameras. So cameras, when we add cameras to a robotic arm, we are enhancing the ability of a robotic arm. It's not just a arm which picks stuff, or which does some manual work. Now we have empowered this robotic arm with vision. So imagine a robot empowered with vision, and uh, a use case is like trying to defuse a bomb. So now that the robotic arm has a capability to view the bomb, to understand the circuit, it could pretty quickly take decisions and defuse the bomb. On the other hand, imagine a manual robotic arm where uh, a, a technician is operating it, and he's looking through his eyes to defuse the bomb. It could take some time, and there is a high possibility of error rate. So, and there are multiple use cases for robotic arms that have built-in cameras. Like, it could handle materials, it could help in transportation, process, and quality control. There are a couple of videos here that I would like to show the show how robotic arms have empowered when we add a camera to a robotic arm. There's this.
We recently shared a video where we showed how our VIM 201 3D vision system is capable of picking objects off of stacks and sorting them by size without hesitation or stopping to get oriented. Today we'll take on a new challenge, visually picking an item that is moving. We'll be picking boxes from a conveyor belt that is not synchronized in any way with the robot. To pick a moving object, we have to identify it and instruct the robot to approach it with a known tool center position. We call this visual servoing. To illustrate the concept, here you see a robot following a moving golf ball in 3D space. For our conveyor demonstration, the object we'll pick is nothing special. It's a Jell-O box. What's different is that we'll randomly orient these and place them on a conveyor moving at 250 millimeters per second. The robot will then visually locate them, pick them up, and place them in the box you see at the left. We've set the box on the conveyor with the conveyor turned off. Our object finder locates it and identifies the velocity at which it is moving, 0 millimeters per second. Now let's turn the conveyor on. As each box passes the camera, you can see its velocity on the screen. If we freeze the frame, you can read the velocity clearly. So we've located our object and detected its velocity without any conveyor instrumentation. Our vision system is detecting the motion on its own, and it has the information it needs to direct the robot to pick up the box. We've never seen an arm-mounted camera guide a robot to pick up a moving object. We believe this is an industry first. The camera and the objects to be picked are both in motion. Let's watch. Notice that the boxes are oriented every which way at varying intervals and various placements on the conveyor, and yet the vision system consistently locates them and completes the pick. Also notice how fast this operation runs. This is a 1 meter per second UR3 robot, not some 4 meter per second industrial robot, and yet our average cycle time is under 3 seconds. To To be more precise, our average cycle time is 2.84 seconds, and we are working on additional path planning optimization that will cut that time down even further. Bear in mind that our vision system is running on an i7 class PC and would be able to keep up with much faster robots. For example, on a 4 meter per second robot, we calculate that our cycle time will be around 1 second, possibly less. Here's a surface level view of this operation. To dramatize how we don't care about the orientation or placement of the boxes, as long as the object is in the pick zone, we'll now slide them down a makeshift ramp onto the conveyor. While crude, it's another illustration of how tolerant our vision-guided system is of variation in the scene. The VIM 201 3D vision system will be available soon. You can see how its power and flexibility open up hundreds of applications to automation that were previously impossible or too expensive to automate. It includes not only the camera, but also a software development kit that makes our special capabilities available to custom applications. And it also comes with QuickPick, our own easy-to-use pick-and-place software application. For more information, visit our website at visualrobotics.com, where you can also subscribe to our newsletter. Be sure to visit and subscribe to our YouTube channel as well.
Yep. So yeah, we have seen how the robotic arm is performing more efficiently when a camera is added to that. So, and there are multiple use cases around the computer vision with robotic arms. Yeah. With that, yep, we conclude our presentation. We wanted to showcase the importance of robotics and mechatronics in warehouses because going in lot of warehouses are not much empowered. If we take examples of the market giants like Walmart, Ecuador, Amazon, they have good capabilities, but a lot of other warehouse systems are lacking these technical advantages, and there's a good scope for students like you to jump in and grab the opportunity. Yep. And Shashi, feel free to add any points.
I think the main intention of this presentation for us was that if we can provoke some of you guys to start your own startups or start thinking about how to manufacture some of these things that are quickly prototypable. Because one thing is, this is an expensive industry, unlike your typical computer science startups, which are very inexpensive in the sense you can sit at home and build your own website and get started with a startup without any funding. But that's not going to happen here in this space. So you need large funding. So one thing that you guys could start targeting is start with something small, basic robotic arm store kind of a thing, and then start building from there. Try to get some industry funding, start building small tools that can be quickly sold off to large warehouses or large enterprises. And from there, probably you can scale to much bigger mechatronic systems that can solve large scale problems. But the idea is start small, go big later. So there are a lot of interesting spaces, at least within India. I think almost everything is unsolved. We have barely got few things that are marked around. Most of these warehouse mechatronic systems are completely open for market. Even smaller tools, gadgets like temperature measurement sensors, even these are probably not manufactured in India at large scale. So there's huge room for startups. Even some of the smaller sensory uh, control systems, you can start with those which are inexpensive, and you can quickly prototype them, and from there you can start scaling towards much larger industry engagement. So yeah, I think that's probably what I wanted to see, if there's anybody who's actually interested in probably trying some of startup ideas from this presentation. I think I'd be more than happy. Yeah.
Yep.
That's it from me, Karthik.
Yeah. Thank you, Shashi. Yeah. Thank you, Dr. Vasu. Yeah. I think
Yeah.
we could conclude our presentation.
Yeah, now the participants are now open to ask questions. Okay, so I will unmute you. You please ask directly the questions to the. Um, okay, so now the participants they can unmute themselves and can ask.
Hello, sir. Can you hear me?
You can ask.
Can you hear me? Oh, thank you so much for it's a very great session. I have two questions. One related to that Amazon video you have shown. In that one technology they show that okay, there is a selection of item. Then as per the selection of item, the box size has been picked. And according to the tape size also they have chosen. So what is the technology behind that one?
So when we know the box dimensions, it could be a pretty static table. Imagine in the database you create a static table which has, okay, if this is my dimensions of my item, this is a related box that should be picked. And whenever they scan the product, they know the dimensions of that product. That again maps to your box that needs to be picked. And based on the length dimension and the width dimension or the height dimension, you can calculate the length of the tape that you want. If your length is 10, let's say 10 centimeters, and height of the box is 5 centimeters, or maybe you need like 10 plus 2.5, 12.5 centimeters of tape should be good. Or 10 plus 5, 15 centimeters of tape, like 2.5, 2.5 goes on the other side. So 15 centimeters of tape should be good. So it's all predefined.
I
Like
think these are
the previous.
mostly lidar based or computer vision based
So
volumetric
it's a
computations.
PLC, it's a PLC programming kind of thing.
So you'll probably use a lidar based sensor. I mean, I'm not sure how PLC works,
Okay.
but does it use any sensors underlying or?
No, PN. I am asking that the technology is that, but is there any sensor available based on that?
Yeah, I mean, ideally you should use a lidar or a computer vision system to compute
And
the
next,
volume.
But
thank
in
you,
the
sir.
video, if we have seen in the video,
Manual.
the worker is picking it manually.
Yes,
So
yes,
when he
manual.
scans it, when he scans it, when he scans the item, there could be a screen on which it pops up like pick box type A or box type B, and he is manually picking. And
Okay,
the
sir.
machine that dispenses the tape, it's a simple math calculation that it does behind the scene. But automating
So
that would
there
be
are
a
only,
really nice area. Yep.
I think there are only finite amount of box sizes that you can produce. You can't manufacture arbitrarily any box sizes. So that's where the box type A, B, C, these things come into picture. There are probably only 5, 6 types of box types. Once you scan the item and you know its volumetric dimensions from a lidar-based sensor, then the next step is to pick whichever is the largest box that is larger than the item size. And then I think you fit it to that. So you also have to take care of the counter or the packaging counter that adds some more volume on top of the item volume. But yeah, I think you have, as you have rightly pointed, there are a lot of opportunities for automating
Yes,
some of these smaller problems, and
yes.
that becomes an idea for your startup. From there,
Can
you can
be
go
these
to
three things can be combined and make a one kind of system or something like that.
right. Gradually, you can go on building bigger systems.
Yeah. And next, thank you, sir. The next is that how this AR VR technology will be assist this robotic technology.
Karthik, do you want to
Sorry,
take
I
that
didn't
or
follow the question. I didn't follow the question.
augmented reality? I think how is augmented
Augmented
reality?
reality and virtual reality will assist this robotics technology.
So that's an interesting area again. It depends upon on the use case. Let's say we want to train a robotic arm, and we might not have the real environment ready for to train the robotic arm. So what we could do is we could create an augmented reality or a virtual reality environment with which the robotic arm could play with, and it could start training by itself. It could understand the environment parameters and it could train by itself. And once your real environment is ready, your robotic arm should also be ready to interact with the real environment.
Yes, that can be one review. Thank you, sir.
Participants, any other questions? Hello, you can ask any questions. Just whatever the question you asked for AR VR. So just I want to whatever the Karthik has told. Just I want to extend a little bit. So one of the thing what this AI and VI is mainly used if you want to make assembly point of view. Suppose if you want to have the assembly point of view, yeah, and we are going to be having some expert engineer will be in some other country like Germany. Okay, so you can able to incorporate that expert in this particular assembly line if any particular fault detection is going to be occurring. That is how you can able to use AR VR. Okay, so one basic example just I want to share with you in our college at Warangal is we have brought one metal 3D printer from France. Okay, so that has been installed in our NIT Warangal. It is nearly costing some 5 crores like that. But due to this pandemic, the assembly engineer has not able to come to because all flights has been cancelled. So no engineer has to be came to here to install that one. Okay, so what they have done is that engineer they have provided us this Google Chrome glasses. So with that we have the engineer is to give the suggestions wherever the fault is going to be detected or how you can able to assemble that particular total system. Okay, so with this AI VA technology, we ourselves, our own technicians and our lab technicians, they have installed the total 3D printer, metal 3D printer in our NIT Warangal. That is one the live example how I can give you how you can able to use the AR VR technology in a real application. That is how you can able to incorporate that one as the Karthik has rightly pointed. Presently, this AI we are presently we are going to be using for the training of the skilled workers. So we will have suppose we are going to be having one skilled environment will be created in the virtual environment and the worker will be given to you will be exposed to that particular virtual environment and he will be graded. So how much skill? So he will be A grade skill worker or B grade skill worker, or he has not done properly, then one more exam has to be conducted like that. So that is how now present the AI VR is going to be used. So in future, what I have told is that is the best example what we have used the AI VR. Okay, so I think I have cleared your doubt.
Yes, sir. Thank you, sir. Thank you, sir.
So if you have any other doubts.
I see one question by Mr. Rafiq. How can we manage the supply chain in a warehouse or in a industry? That's an interesting question. There is a lot more macroeconomic variables and the demand forecasting that goes into that. Currently, I'm working on a project which is around based on the historical order information for a particular product on a particular time frame. I'm trying to predict what could the order information or what could the order count could be for that particular product for a future 5 or 6 months. Technically, I'm doing a forecasting. So I'm doing a demand forecasting. So if we could come up with a time series demand forecasting model for a particular commodity, and again there are a lot of external exogenous variables that need to be considered, like your market, PPI, CPI, the cost index, the price index, the GDP. Lot of factors go into that to understand that supply chain. So once we come up with that precise model with which we could forecast the number of products that need to be manufactured, yeah, then definitely that information could be fed to your manufacturing plant, and based on that your manufacturing plant operates. Is that clear, Rafiq, or you need more explanation around this?
Yes, sir. Thank you.
Sure.
One more question there.
I see one more question from Mr. Saumitra. Shashi, would you like to take that, or what's the advantage of integrating IoT with robotics helps in automation?
Yeah, I think that's a very good question, actually. So IoT has a lot of scope in warehouses, especially. So most of these warehouses are distributed. They cannot really operate with your cloud computing. If you look at the amount of computer vision and deep learning stuff that is going on, it's simply not feasible for a cloud system to give real-time responses back. So if you're going to actually run a deep learning LiDAR-based system to track a automated guided vehicle system, that's going to probably take 2-3 seconds to get a response back from a cloud-based system. Before that, few people would have been dead under that vehicle. So these systems are actually going to be built right at the warehouses. That's where IoT comes into picture. So most of this computation has to happen in-house, inbound. All this sensory information has to stay locally at the warehouse, and probably it can be synced back at the end of the day or something like that. But major chunk of the computation has to happen remotely through edge computing or something like that. Even the networking has to be quite fast. So all these individual devices have to be connected to each other at a very high speed networking. So I think these are the IoT problems that you can foresee in warehouses at least.
And to add a couple of points, maybe I would like to emphasize on the term automation. Let's go back and consider the same example that I discussed. Right, you have sensors through which the data is flowing through. It's a streaming data from the sensors. So if you want to automate the operations of a robotic system, the more important, the crucial fact would be how streamlined your data is. So integrating the IoT systems with robotics is really crucial there. So again, it goes back to Shishi's point, where your computations or your data streaming data should stay in house for the automation process. But at the end of the day, maybe we could take that, decouple, and push it to cloud for later analytical purposes, maybe for dashboarding, reporting purpose, or maybe to throw some more analytics around that.
We will take one last question and we will end up the session. Can anyone ask one last question? No other questions? Exam, I will ask. That is not to the experts. You ask what is the last question to the experts. Okay. So if you are no more questions, then we will conclude the talk. So thank you, Karthik and Shashi, for sparing us. That is, you are sparing our time. Though it is midnight for you there, you have bear our time to give some knowledge to our participants. So I understand what is the problem, how it is we sitting at 2 o'clock in the night. I think you are in a sleepy mode. So once again, I thank you for your nice session and giving enlight to us. And giving what are the exact industry problems what we're going to have. So what are the problems they have discussed? They have discussed some three problems. With these three problems, if somebody want to start any particular startups, as now present in all, our government is also promoting to have a startups with that. You, as this Karthik has proposed, you make a small component in a mini scale with that, and after that you can able to extend to that bigger level to a industry what going to have. Okay, so these are all some of the problems what they have given you, so which will able to give you some insight how you can able to start one startup or how you can able to manage the things with this. So with this, I will thank once again the Karthik for
Thanks for the opportunity, Dr. Vasu. This is really nice for me and Shashi to interact with students and professors. Yeah, thanks for the opportunity.
yeah. So then okay. So then we will conclude this meeting. We will go ahead for the further.
Yeah, thank you.
So
Bye.
yeah. So yeah, you can stop the sharing. Yeah, thank you. So participants, I think we will you will be shared with I think Upendra. Are you there?
Yes, sir.
Yeah,
Yes, sir.
you explain what is the exam procedure and what the things they have to do. And exactly on 4 o'clock, we will start the inaugural function, what we're going to do. Okay.
Okay.
So please
Sir,
explain.
yeah, in short duration, I'll be sharing the link. So that is a Google link, Google form. So you will be prompted 20 questions. Duration will be 30 minutes. And don't panic. This will be very simple, general questions. Very basic one related with the topics which is relevant to this or conference, FDP, whatever we are conducted. So means you will pass. So don't panic and just give your 100%. 30 minutes is the maximum duration. And so just now I'll share maybe in 5-10 minutes. Before that, I will share the feedback. Okay. So someone was asking about the feedback. So yeah, this is the feedback.
Sir, you are sharing the link to mail or WhatsApp to exam?
Here only WhatsApp and here. Means WebEx first I'll share here. So this is a feedback form. So you can share, fill the feedback form. Just now session completed. So should I share now or you want some time?
Upendra, you can share it, no problem. They will finish because we have to start the inaugural at exactly 4 o'clock because our director will be comes 5 minutes before only. Please, all participants, we stay here only because our director will be more prompt. So he will be 5 minutes before only he will join and he want finish off exactly by 4:45 maximum. Okay, 4:40 we will finish off everything and we will call a day. Okay, so please bear with us. Okay, so don't go away and you be here and it will not good look for me also if nobody is there, not there. Okay.
Okay. So please find the question which just now I am sharing. So this is the link. Also duration will be for 30 minutes. And please remember, this is the compulsory thing which you have to, you have to write this exam. This is a compulsory for you to get the certificates. So make sure you write your details correctly here. Your name, whatever you write, that will tally with whatever you have entered earlier. So the name will be on the certificate. Sir, should I share the same thing on WhatsApp also?
Yeah, you can share it, no problem.
Okay.
Yes, sir, that will be comfortable little.
Yeah, because a lot of participants may be accessing from phone. So let's see.
Mobile only we are working.
Yes, sir. So first, this is a feedback form, and second, I'll share that.
So you please share the attendance after the validatory session. So once that is going to be the final attendance. Upendra, okay. So today you share the feedback session after validatory. Don't share now.
Overall feedback or?
Okay. Exam, okay. That feedback will be that is the attendance. No, that is going to be required.
Okay, sir.
Vasu sir, what is the time for valedictory function? Shivram on this side.
4 o'clock. 4 exactly. 4 o'clock. The sir will come. Most
Okay,
probably
okay.
it will take 40 minutes.
Okay, okay.
So,
Sir, then I'll join around 3:50 because that NEP meeting is also going on in department.
Yeah, no problem. No issue.
Okay, okay, sir. Okay, thank you, sir.
It's not opening, sir.
What's the issue, sir? Can you confirm?
Sir, for the assessment session.
Hello.
Yes, there was some disturbance. Yes, please continue.
Sir, actually the form is not opening up. It is asking for something upgradation. After payment, you can refresh this page.
Okay, sir. Actually, we tried with the
Test which is
time limit.
sent.
Slowdown note. I'll just share that Google form. So there is no time limit for that.
Hey, how we can start? Actually, it is not able. It is disabled from where we have to start the session for filling
Okay,
the test.
I'll just share the second link.
Okay, okay.
So I just now share the link. Please use that one.
Google is giving now only 50 participants allowed. So if it is more than 50 means is asking for payment. For Google Meet also we have to go like that.
Sir, at the end of that Google link, it's written submission tracking ID do not change. And your answer, sir, we fail to understand what is this, sir? Excuse me, sir, are you there? Upendra, are you there? Participants, can you listen to me?
Yes, sir, we can listen to you.
Yeah, it is open. The Google.
Yes, sir. Link is open, sir.
No.
We have started answering. No problem, sir.
At the end, it is written that submission tracking ID do not change. This is important for tracking purpose. Your answer, what we have to written in there.
Yes, sir. We are solving the Google form.
Yeah. So once you have written all the questions, you can press submit.
Okay, sir. Okay.
But with this is the asterisk mark is there. We have to fill something in this.
What? Yeah, please. If you have any query, please let us know.
Oh, am I audible?
Yes, sir.
Hello. At last of the Google form, submission tracking ID do not change. In that, what we have to write?
Do not change anything, sir, because actually we tried with the time limit, so maybe you are having the time limit one. So do
There
not
we
change
have to
anything,
give
just
some
submit.
answer, na? We have to
No,
give some
nothing,
answer,
sir.
na?
Nothing.
Star
Just
mark is
submit.
there. Not required. Okay.
Not required. Do not change anything, sir.
Starting the second session today. Starting the second session today. And this session, if you see, its number is your seventh lecture is coming up. Now it's already ready. We have with us who is a professor from IIIT Jabalpur. And I know her around for last 3-4 years. We are discussing about the project, and she has really supported when we have conducted in-campus machine learning, deep learning program in 2019. And I can really see it was really motivated to me. Such a senior lady was so active.
I think, sir, by
During the
mistake, Mr.
lecture,
Sarkar has kept his mic open.
whole day, and, 2 days she has taken marathon sessions, and that was really touching to me. And today, for this second online program, she has agreed to deliver a talk on basically deep learning for detecting models and their application.
Sir, we are not able to get the tracking ID. Can you clarify that?
Hello, sir. Sir, in the last, what about the tracking ID? What we should do for finding the tracking ID? Hello, sir.
Yes, sir. Am I audible? You need not to change anything in the tracking ID. You just submit whatever the value is there.
Anything?
Yes. No, do not change anything. There is something already written there. You just submit.
But in my particular Google form, it is not seen, sir. That's why I have to ask the question.
I think there shouldn't be
Yes,
any
sir,
tracking
nothing is
ID.
written. It is a blank to be filled.
But actually, it is star mark, so it is not possible.
So let me. How many of you are facing this issue? May I know?
I think, sir, we all have the same problem.
Yes, sir. I think it must be with everybody.
Okay.
Please
Sir,
solve the solution, sir.
when we changes the browser, at that time it shows. Otherwise, in Google Chrome, it is not showing.
Okay. Sir, you choose which option, the first link which I shared or the second one? Sir, if the problem persists.
Second link, sir.
Sir, second link.
Okay. Sir, what if you write any random number?
Okay.
Please try that one. If I don't get the response here, then I'll let you know.
Okay.
What should we fill, sir?
Anything you just write random thing. I'll check the response here.
Okay.
Sir, I just write 1, 2, 3, 4, 5, 6, and my response is recorded.
Okay. Sir, may I know your name?
Professor Jitendra Prajapati.
Okay, let me check, sir.
Okay. Can you receive it?
Checking, sir.
जितेंद्र प्रजापति जितेंद्र काशीराम ऐसा नेम लिखा होगा.
Yes, I got it, sir.
Okay.
Means you can write anything. Yeah, that is not mandatory, but anything you can write.
Okay. Thank you very much, sir.
Welcome, sir. Sir, we'll send you one more feedback just after the validatory function. So
Yes.
please be present only.
Yeah. Okay.
Okay, sir.
Upendra, can you ask Arun to call me? He's not lifting his phone. One information is required regarding his relieving letter.
Okay, sir. Sure.